Welcome back, and we are going to press on with talking about those other formulas that were mentioned in the first video. Double angle, power reducing, that's the new one that we don't really use that much, and half angle formulas. So before diving too far into all these, I think it's prudent just to kind of continue to put our skills to use here. So what I want you to do is pause the video and write out expressions for each of these. So sine of 2u, for instance, as a hint, 2u, I can write that as sine of u plus u. Okay, so we learned identities for angle addition, right? Try using those on each of these for sine, cosine, and tangent. Resume the video when you're ready. And here are the answers. So sine of 2u is 2 sine u, cosine 2u, has three equivalent forms, all making use of the identity, the Pythagorean identity. Cosine squared plus sine squared is 1. So this first one's kind of the standard one, and then you can derive the other ones by using various versions of that identity, that Pythagorean identity. And so tangent of u is also given as there. These are the double angle formulas. Okay. So then, just as a quick example connected to all this, we know that if sine of theta is 4/5 and theta is in quadrant 2, and we want to find the exact values of each of these. So just a quick little sketch. So theta is in quadrant 2. Okay, and we know sine is 4/5, so then that means cosine is -3/5. And we want to find these identities. So for instance, if we were looking at sine of 2 theta, right, we know this is 2 sine of theta cosine of theta. So then this is 2, and then sine of theta is just 4/5. Cosine of theta is -3/5. So then I multiply all that, and I get, let's see, that'll be 10. Okay, we'll just do it longhand. -24/10, and that reduces to -12/5. Okay, and then cosine of 2 theta. I'm going to use the version that it's cosine squared theta minus sine squared theta. So then this is -3/5 squared minus 4/5 squared. And so then that's going to be, let's see, we're talking 25ths, and that'll be 9 minus 16, so -7. And then tangent of 2 theta is 2 tangent of theta over 1 minus tangent squared of theta. And so tangent here is -4/3. And then 1 minus -4/3 squared. And so I get -8/3 all over 1 minus 16/9. And so this is -8/3, and then that'll, in the denominator, I'll have -7/9, which then I have to multiply by the reciprocal, so 9 over -7. So then this is a hot mess of, well, actually it's not too bad. That's 3, that'll cancel, so I get -24/7. Okay, so mod algebra, these are the answers. Okay, mod algebra and arithmetic. Okay, now that's just a nice little example of double angle formulas. There are some other formulas that are connected to all these. Okay, so if we look at this cosine identity, right, we saw this one pop up, and we want to look at it in a little bit more depth. What I want to do is now maybe rearrange this just a little bit. And instead of solving for cosine as it is currently, I want to solve for just sine squared. So according to that algebra, right, I would have to subtract 1. So I'd have cosine 2 theta minus 1 is equal to -2 sine squared theta. And then rearranging completely, so then divide by -2. That is to say, I could write this as 1 minus cosine of 2 theta all over 2 is equal to sine squared theta. Okay, and this version of the identity, that double angle identity, is very useful. You can do this similar manipulations with each of sine, cosine, and tangent, and you get the power reducing formulas shown on the left. Okay, and if you don't like the square version, you also get you take the square root of each side, and you get the half angle formulas. Okay, so the only thing is that when you're working with the half angle formulas, you need to be careful because, again, you introduce a square root when you took the square root, right? So there is a plus and a minus here. You need to decide which one based on the quadrant where this theta over 2 lies. Or rather, in this case, it would just be where theta lies. Okay, so wherever this angle is, that determines the sign in front of the square root. Okay, so just to put this to the test, we want to find the exact value of sine of 165. Now, yes, we can use angle addition with this. 45 plus 120, great. That's not the point here. We want to look at this angle here as theta, and then recognize that 2 theta would be twice as much, so 330 degrees. Okay, and so I want to try to use the half angle formula for sine to help me do this. So I want to do sine of 165 degrees is equal to, and then I need to decide on the plus and minus. I'm going to leave it plus and minus for now. Erase one of them here in a moment. 1 minus cosine of 330 degrees all over 2. Okay, now if my memory serves me correctly, 330 is in quadrant 4, so this is 330 degrees, and sine in this quadrant is, or sorry, my bad, I made the mistake again. So I want to look at not 330, but I want to look at 165. So 165 is over here in quadrant 2. Okay, so again, you're using this angle to determine the plus and minus, and over here sine is positive, so I'm just going to get rid of that minus. Okay, so continuing the calculation now, just as a reference for me, okay, now I can look at 330 because I need to know cosine of this. So then cosine, let's see, that's 1, 2, and then square root of 3. This is actually -1, but I don't need that. So then this is going to end up giving me square root 1 minus, and then cosine here's root 3 over 2 all over 2. I can simplify it further if I want. I can write this as the square root of, let's just make it nice and simple, 1/2 minus root 3 over 4, and that's another way of expressing that same thing that we found in the previous, well, the one we found in the previous video was for cosine, or for tangent, I'm sorry. This would be the sine of that same angle. Okay, so again, this problem, you can either try and use angle addition or angle difference. You now have the capacity to do you can use double angle formulas, you can use half angle formulas as well. Okay, so keep all these tools in mind.